So first one, when I have the same base and multiplication, what do I do with my exponents? Same base multiplication, Southwick, what do you think? You add them. So we're going to add these exponents, but you can't really add them right now as is, so you need to make them have common denominators. So I'm going to change this to x 3/6, so I can add them. And then this is going to be times 2 times 2, so 4/6. Now we can add our exponents. Denominator stays the same. Base stays the same, so it's going to be what? 7/6? All right. Next one is power to a power. What do I do when I have power to a power? What do I do, guys? Multiply. That was better than the last one. Yeah, multiply. Remember, 2 also has an exponent. It has an exponent of 1. So you do have to multiply 3/4 to both the 1 and the 1/2. So it's going to be 2 with a 3/4 power, and v multiply straight across here. So 3/8. Can it simplify any of those fractions? I don't think so. So we'll say, so far we've done add, and this was multiply. And then the last one, when I have the same base and division, what do I do, guys? Subtract. Okay. We are dividing, but we are going to subtract our exponents. So 2/3 minus 1/6. Again, make sure you have common denominators first. What should I change the top one to? 4/6. And then this bottom one will stay 1/6. So now we can subtract. It's going to be c to the what, guys? 1/2, because it's going to be 3/6, which you can simplify. Okay. Like I said, today's kind of weird. We're going to look at this, and then I'm going to do a few more examples on the whiteboard just to help us out. Okay, let's just read it together. You can use rational exponents, rational meaning fractions, or things that can be written as fractions, okay? Without a 0 on the bottom. You can use rational exponents to represent radicals. So it's saying, hey, if you have something in a square root, you can use a fraction exponent to represent it. Cool. In a radical expression, the number under the radical symbol is the radicand. You already learned that. The number underneath the radical, called a radicand. The number in the crook, kind of a fun word, in the crook of the radical symbol is called the index. So this part right here is the index. The equivalence of radicals and rational exponents is expressed below. If the nth root of a is a real number and m and n are positive integers, then that is true. And I can't really read that out loud. But I'm going to do some examples on the whiteboard to help us out. Okay. So let's just say we have c raised to the 3/4 power. This is what it's saying on the bottom of the page. If you have c to the 3/4 power, okay, you know that if it's c to the 1/4, then it's the 4th root, right? So this 4 is telling you it's the 4th root. So we do the radical with a little 4 in the crook. But the 3 is actually raising the c value to a power. And so this is the 4th root of c cubed. Kind of weird. So the bottom number tells you what the root is. The top number tells you what to take the base to a power of. Another way you can write this is what it's saying on the bottom of that page is 4th root of c, all of that to the 3rd. That's another way to write it. So if you want to make a little key for yourself, I don't know. It's like whatever you have, the base, the top number is going to be the power. The bottom number is going to be what you put in the crook. Or sometimes it's a little bit easier to say inside, outside. Crook, what a fun word. Looking at this, it's a to the 5 6. So what root are we going to use? The 6th root. Yep, because if that 5 wasn't there, it'd be 1 6, and so it's going to be 6th root. So I know right away that it's going to be a to the 6th root, or the 6th root of a. And then 5 is the power. So you can either put it inside, like this, a to the 5th to the 6th root, or you can do the 6th root of a raised to the 5th. These are the exact same thing, because you'd be doing 5 of those. Multiply it out. You will have one like this on your test, so I would pay attention right now. What power does 5 have? 1. Thank you. So is 5 being raised to the 3rd power? No. So is 5 going to go inside the root? No. Okay, so it's 5 outside of a root. What root is it? 1, 2, 3, 4, 5, 3. The 3rd root of x. And x is only being raised to the 1st power, so you're done. Now, you could do power to a power here. It's really not necessary because all of this is being raised to the 2/3. So I would just do it all at once. So what root are we going to use? 2nd, 3rd, 4th, 5th? 3rd. Or the cube root, we should say, probably. The cubed root of what? 54y. Okay, since it's 54y, all of that to the 2nd power, on this problem, it makes more sense to do this. You could write it in parentheses in the radical squared, but that would just look kind of weird, and so this is probably a better way to leave it. Okay, so you have s, and then we're going to have a fraction here. So which number, guys, which number goes on the top? 2. Which number goes on the bottom? 3. Done. Next one, is 12 in the square root? No, so it shouldn't be raised to a power, so just put it out in front. But your base is x, and it's going to be a fraction. Which number goes on the top? 4. The power, and which number goes on the bottom? The crook. For y is all of that is being raised to a power, okay? So we can put this in parentheses still. 4y to the, what number goes on the top? 5 is a power, and what number goes on the bottom? Which number is in the crook?
2.
2 is implied.
Oh, right.
You can leave it like this. What thing here is being raised to the 8th power? The a. 256 is not. 256 has a power of 1. Okay? So let's split it up separately. 256 is going to be multiplied times a. They're both going to have that fractional, the rational exponent. On both of them, what goes on the bottom? 4, because they're taken to the 4th root. For 256, what goes on top? 1. 256 is being raised to the 1st power, and then a, what goes on the top? 8. Let's go ahead and evaluate 256 to 1/4.
4.
One way you could do it is take the square root twice. Ridiculous. So 4 times, now what should I simplify a to the 8/4 to? A to the 2nd. So let's actually get rid of the dot. 4a to the 2nd. That looks so much better. Have a cube root button. It's math 4, but you don't have a 5th root button. So can someone raise your hand and give me a suggestion on how I should type 32 to the 5th root? unless you can do it in your head, which would be nice. Emma?
32.
Yeah, to the 1/5 power. 3, and that makes sense because 3 times 3 is 9, times 3 is 27. I can do that in my head. Ellie, what's the 5th root of 32?
2.
Good. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 5 times. Cubed root of 64.
4.
Is that right?
Yeah.
You can think of it like this. 4 times 4 is 16, times 4 is 64. That's one you can do in your head as well. And then the last one, well, you should be able to do that in your head as well. Oh, wait, no. Never mind. Yeah, okay. So what number 4 times gives me 81? 3. 3 times 3 is 3 times 3 is 9, times 3 is 27, times 3 is 81. But you could also type it in your calculator and get the same thing if you're having trouble. 32 to the 5th power is 2 because 2 times 2 times 2 times 2 times 2. Wait,